In this segment, we're going to talk about how you actually calculate the control limits for the X bar and R chart, as well as the middle values, the X bar and the R bar lines. So the control limits for the X bar chart, which again is just the average chart, is as follows. The lower control limit for the X bar is simply the X bar, which is just the average of all your averages, minus A2 coefficient times R bar, which is just your averages of the R's. The upper control limit for the X bar is very similar, X bar, but instead of minus, it's going to be plus coefficient A2 times R bar. So we say, well, wait a minute, what are these A2s? To determine what A2 value to use, you determine how many parts you measured in a given period of time. Let's say that you measured 3 parts at 8 o'clock, 3 parts at 10 o'clock, 3 parts at 12 o'clock, then your N would be 3. If you measured 5 parts at 8 o'clock, 5 parts at 10 o'clock, 5 parts at 12 o'clock, etc., your N would be equal to 5. Let's assume for this example that we measured 4 parts every 2 hours. So our N would be equal to 4, and we would use 0.73 as our A2. So we would say X bar minus 0.73 times R bar, and X bar plus 0.73 times R bar. Now, X bar is the average of all the X bars in your table. Let's go to the control limits for the R chart. It's going to be the lower control limit for the R is equal to D3 times R bar. And remember, R bar is the average of all the R's in your data table. So what is D3? Let's assume again that we're taking 4 parts every 2 hours. So our N equals 4. And so our D3 is equal to 0. So lower control limit for R is going to be equal to 0 times R bar, which is of course going to be 0. The upper control limit of R is going to be D4, which is again N equals 4. Here is our D4, 2.28. So we use 2.28 times whatever our average of our R values are in our table. So in your own words, what does N mean? It just means how many parts I'm measuring in a given period of time. If I'm measuring 5 parts, N equals 5. If I'm measuring 7 parts every 2 hours or 7 parts every hour, N is going to be 7. When do I use D3 and when do I use D4? Well, you're going to use D3 whenever you're calculating the lower control limit for the range chart. You're going to use D4 when you're calculating the upper control limit for the range chart. Here are some sample calculations. So what is my sample size, or N? Well, let's see. I am taking 1, 2, 3 measurements here, 1, 2, 3 measurements here. So my N is equal to 3. So what values of A2, D3, and D4 will I use? Well, let's see. N equals 3. I scroll back up here. I'm going to use 1.02, 0, and 2.57. What is my N, or sample size, in this case? Let's see. 1, 2, 3, 4. 1, 2, 3, 4. My N equals 4. So what are my A2, D3, and D4 values? So N equals 4. I scroll up here and I say, oh, my A2 is going to be 0.73, my D3 is going to be 0, and my D4 is going to be 2.28. Let's do some sample calculations to show you how you calculate X bar, range, X bar, and R bar. Let's see what our sample size is. 1, 2, 3, 4, 5. N is equal to 5. That's important to remember. To calculate my X bar at 7 a.m., I just add up these 5 numbers and divide by 5 to come up with my average. And for my range, I come over here and I say, what is my largest number? Oh, 14.7. What is my smallest number? Well, I have 13 here and 13 here, so it doesn't really matter. 13 is my lowest number. and so my range is going to be 1.7. 8 a.m. I do the same thing. Add up these 5 numbers, divide by 5, and my range is going to be my largest number minus my smallest number. Oh, here's 14.9, which is my largest, and 12.2 is my smallest, so that gives me 2.7 range. And you're going to do that all the way down here. After you've completed the X bars, the averages, and the ranges, you're going to take and determine the average of the averages. And that's simply adding up this, and this, and divide by the number of X bars. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I would add up these numbers and divide by 11, and I would arrive at an X bar, the average of the averages of 13.6. Similarly, for the R bar, I'm going to add up all my ranges and divide by 11 again, and I would arrive at 2.2. So calculating control limits. Here's my formulas. Here is my table of A2, D3, and D4s. And so I go ahead and start plugging numbers in. My lower control limit for X bar is equal to my X bar, which is 13.6 minus 0.58, because I am taking 5 measurements, as you saw in the previous example, per hour. So I use that number times my R bar, which is 2.2, and I come up with a lower control limit for my X bar of 12.3. For the upper control limit of X bar, I take my 13.6, but instead of subtracting, I add this and arrive at 14.9. So now I have my lower control limit for X bar and upper control limit for X bar. For my lower control limit for R, it's D3 times R bar. D3 is going to be 0, so 0 times my R bar, which is 2.2, is going to be 0. D4 times R bar is going to be 4.6. Before we go on, let's just quickly review the SPC charts. What does the X bar chart track? X bar tracks average, because X bar is just another name for average. It tracks how the center of my distribution shifts. What does the R chart track? It tracks my variability, essentially how wide my tails are and how that changes over time. So interpret the X bar chart and the R chart. Well, I look at here and I say, here's my control limits, and nothing exceeds it, so the process is in control. The X bar chart is in control. I look at my R chart, and here's my upper control limit, my lower control limit. Nothing exceeds it, so my R chart is also in control. It is predictable.